Today we're going to talk about how to determine whether your AC three-phase motor is good or bad. And actually, I say AC three-phase, but same principles work on a single-phase motor. Now, usually what you ask me is, can you show me how to Megger a motor? And the Megger test is an important part of checking your motor out, but it is not the only test. We could do some other basic tests first to determine whether the motor is good or bad. Which, speaking of good or bad, I know everybody wants to know what is the good or bad value, and that is going to be very dependent on your particular motor. So I have gone ahead and let the magic smoke out of this three-phase fan, and then I have a three-phase fan that I haven't let the magic smoke out of. We're going to do some basic tests on it. And let's start off talking about some different meters that we could use for our testing. So this is the Fluke T6-1000, but mainly we can check our voltage. It does have a clamp here. And we can check resistance. So this is your typical meter that you would see out in the field. And this one right here is very similar. This is the Fluke 381. And it also is going to have amps, and it has more of your traditional clamp that you're used to seeing. Now, when we start talking about Meggers, we're looking for something that can do an insulation test, such as this 1587 FC from Fluke. Now, the question that everyone always has is, what is the good value and what is the bad value? The good and bad value is going to be very dependent on your motor. It's also going to be dependent on your application, which makes that a really tricky question. And so, I get the pleasure of reading all types of companies' checkoff lists when they're accepting a piece of equipment. And, I see things with, ergonomics, paint colors, all that type of fun stuff. I saw one, and I always thought it was really interesting. They required every motor above a certain horsepower. You had to do an amp measurement on it. You had to take the leads loose and do a resistance measurement, and you had to do a Megger test and note those good values before that went into service. And without doing those good values, it's going to be hard for us to figure out the bad value. So what I've done is I have wired our bad motor to our motor trainer, which can actually simulate different types of motor failures. And also I have it wired in parallel with our good motor. Now, you may recall this motor from a previous video. This is the one where we showed how magnetic fields make motors rotate. And let's start off by doing a basic amp check. And I'm going to do it with both the Fluke 381 and the T6-1000. And so we're going to start with Fluke 381. And one word of caution, a lot of people will try to grab all three of them and measure it that way. That doesn't work because the way AC works and the way the offsets in the three phases, your amperage will actually be canceling itself out. So you're going to read a lower amperage. We want to do these one at a time. So I'm going to go ahead and start my motor. We'll let it fully come up to speed. And so this leg is saying 0.9 amps. This leg is saying 1.4 amps. And this leg is saying 0.4 amps. And just to show that it would be the same with the T6-1000, I put it here on this one. Whoops. Okay, I didn't get the T6-1000 on quite quick enough. I knew this motor was on its way out, but I thought I had enough in it. But let's talk about, we would have got the same thing with the T6-1000. I was just going to highlight both of them. But let's talk about what we observed and how we can use that to determine if our motor is good or bad. Because for your particular application, you may not know for sure what the amperage draw should be. Because usually, by the time we're out there, there is something wrong with the motor. And we're kind of like, well, I wonder what it would pull normally. But since we're applying the same voltage to all three phases, we should get the same amps from all three phases. So the fact that one of them's low and one of them's high tells us that we definitely have an issue with the windings of this motor. So I went ahead and took the bad motor loose just so we could see what a good motor would look like. So I'm going to put the clamp around the first leg of it, and we'll go ahead and reset my overload and hit the start. And so on our first leg, we're pulling about 0.6 amp. On our second leg, we're pulling 0.6 amp. And on our third leg, we're pulling 0.6 amp. So if I was having an issue with overloading on the one that had the unbalanced phases, I would be leaning towards probably something wrong with the motor. Now, we still could get an overload on this one, but it could be getting overloaded because of some type of mechanical wear, a bearing binding, or something external. So for the rest of this, we are going to use the 1587FC, although all three of these meters, the T6 1000 and the Fluke 381, and really any typical meter could do this next check, but I know we're all wanting to jump to an insulation test, but the next thing we really want to check is resistance, because if our amperage draw was different between the three legs, it's probably because we have a difference in resistance. So this is our good motor, and I'm going to clip it onto one of these, and we'll clip it onto another one of these. And so on that one, we have 400 and we'll call that 400 ohms on that one. And so then I touch it to this red one right here. And we got 400 ohms on that one. And then finally, I take it off that black one and we touch it to this one. That would be the other one. And we have 400 on that one. So very even across there. Now, the other one we should do while we're here is check them to ground. So I check it to ground. Got nothing there. Whoops, leave that there. And we check the next leg to ground. We have nothing there. And we check this leg to ground. We have nothing there. Now, leg to ground does not mean that the motor's not bad. All we did was check the resistance with a very small amount of voltage. Now, what the insulation test is going to do, which we'll show in a second, is it's going to put high voltage on it. If we have weak insulation, that'll expose that. All right, so now we want to check our bad motor. So we're on our good motor. On this one, we were at 400 ohms. So now I'm going to do the exact same check here. And okay, I have 89 ohms in between these two legs. And I have 247 between those two legs. And then finally, I have 335 between these two. So that follows right along with that amperage imbalance that we were seeing. And so here's a good example. We haven't even got to a Megger yet, and I would call this motor bad. Now, let's go ahead and do the Megger test next. Now, to do a Megger test, we're actually checking our windings to ground. That's the goal of our Megger test. And so I'm going to lay this down, and first I'm going to clamp one of these, the black one, to my case. Now, one thing I like to do, because notice I have these in the wrong position right now, is, did I get a good clamp on this? I'm going to leave it on resistance. I'm going to touch it to another spot on it. I was going to make sure my resistance is very low here. That way I can make sure that, I'm getting a good ground contact there. So now we're going to need to move our leads. And so that's going to be over here on this spot. Now notice on the 1587FC, it has our regular lead, but then there's also two additional wires here. And what that's for is this test lead right here. It actually has a remote button on it to do our insulation test. So what I could do is I could simply plug this lead in and I could switch it over to insulation. And folks, be really careful when you're doing insulation tests. Make sure you pay attention to where your hands actually are at, because this is going to put out voltage when we do it. But what this allows us to do is normally what you can do is you can press right here and we can do our insulation test. That allows us to press the button on the end and also do our insulation test. Now, for my setup, my alligator leads are going to work better, so I'm not going to use this one. I'm going to unplug it. And I'm just going to plug my basic lead back in, because now I can take my alligator clip and I'm going to touch L1. So right here now, I have the ground case on one. I have L1 on the other. I'm going to make sure I'm not actually touching anything. And then for your range, because we have a test voltage range here, pretty much you want your range to be twice what your motor is going to put out. So this is putting out 243 phase. So I'm going to make this 500 volt. And then I'm going to press and hold my insulation test. And so 550 mega ohms is good. In fact, let me just take this wire completely off. That way we can see that. So now we 100%, or we have to go through air to get there. And I press and hold the button, and we get 550. So that tells us that that one is good. So now I'll grab the next one. Now I'll test it. And it's good. And I'll grab the third one and test it. And it also tests good. A lot of people tell me, well, you only need to test one because if there is a leak, then it'll get through the windings to the others. But I don't know. I always test all three just to be sure. Okay, now we're going to use our actual motor starter trainer because with this one, we can simulate those bad insulations that you'll see out in the field. Talk about some really important things when we're doing our motor test. 100%, just like I had on this one, always, if you're doing a Megger test, have the motor leads disconnected. And really for your insulation test, you want to do that too. That way we're not having to deal with feedback coming through here. Now I have this trainer set up that really, if this light's not on or that light's not on, it is disconnected because really we test this motor every week, or we run this trainer every week in our class. So the first thing we're going to do, just like the previous one, is we're going to start off with a resistance check. So we're going to switch it over to resistance. And then make sure you pay attention to where your leads are supposed to go, because I'm famous for leaving the leads in the wrong place. So they could be over there for resistance. And then we're going to take our leads. And actually I'm going to slide the sheaths down, which we should do a video about that sometime. If you have this type, make sure you leave them up normally, because that does give you a higher level of protection. But we're going to touch between T1 and T2. And we have about 208 ohms. And then to T3 and T1, we have about 204. And then finally from T3, we have about the same. So we're even across all these, so we're probably good. While editing this video, I realized there was one thing that wasn't really clear. Our good motor had 400 ohms on it. And then we got over to this setup and it was showing 200 ohms. But we have two motors here. So we have a motor with the fan and everything in it. And then we also have the motor, just the casing, so we can actually talk about how motors rotate. And so since I have them in parallel, that's dropping my resistance down to 200. And while we're here, we're going to go ahead and do a resistance check to ground also. So I'm touching ground. I touch T1 and I have nothing. I touch T2 and I have nothing. Touch T3 and I have nothing. So that tells us that it looks like the motor is good. And now we want to do the Megger test to be sure. So here's where I'm going to switch my leads. And we'll go over to our insulation test. And I'm on 500 volts. I'm going to put one into my ground. And the other one, I'm going to touch to T1. And I press my insulation test. All right, and that one says it's 550 mega ohms, so we're good. And then we go to T2. 550, so we're good. And finally we go to T3. 550 mega ohm, so we're good. So my switches here simulate various different motor issues that you can have. So we're going to turn switch 1, and we're going to do the same thing. And each time we're going to start a resistance check, because there's a high likelihood that a resistance check may show us what we're looking for. So I have my leads in the right place. I am on resistance, and I am going to check between T1 and T2. Okay, check my leads, make sure. Must not have them up in there good. T1 and T2. My leads are up in there good. And I'm showing an open lead on that one. So T2 to T3. Oh, open lead. And finally, T1 to T3. And we have pretty much an open lead. So this one right here is showing you what it would look like if you had a total meltdown on your motor. So without even doing any insulation check, we could tell, yeah, the windings are definitely burnt out in this situation. So let me go over here to switch 2, and let's do it again. So now if I go from T1 to T2, all right, we're at 158 ohms. T1 to T3, we're at 20 ohms. And finally, T2 to T3, and we're at 158 ohms. So in this case, there's definitely something wrong with that one winding. But since there's an imbalance in the resistance, that would be a good sign that that motor is bad. And finally, we go to switch 3. Now let's see what it simulates. So each time we're going to start the resistance check. A lot of times it will get you there with a basic meter. So we're showing 204 ohms between T1 and T2. 203 ohms between T1 and T3. And 204 between T2 and T3. So really nice balancing of our phases. And now we're going to do a resistance check. So I'm going to put my ground over here. And then we touch T1. And we only have 22 ohms. And then we touch T2. We have 226 ohms. And finally T3, we have 226 ohms. So that would tell us T1 definitely has an issue to ground. Also, this is one of those situations where people tell me, well, you only need to check one on the ground because it'll bleed through. I still check all 3 up. But so, really at this point, we don't even need to do an insulation test because really it checks out good. I mean, it checks out bad with a basic resistance test. Now, what does it actually mean if you do have some resistance to ground? You're going to find that varies a lot by industry. Yeah, if you didn't know it, you're in our training center, and we get a lot of different people in here, and depending on where they come from, they have a lot different viewpoint on this. I mean, if you're in the water industry and you have resistance to ground, you're like, yeah, probably flooded the room. If we just take that motor and dry it out, it'll be fine. Probably the food industry is very similar. Now, if you're in a really dry environment and you get this, then that's usually where, oh no, we got something really going wrong with the motor. So even then, there's a lot of gray area as far as what is good, what is bad. And finally, we have switch 4. And so let's see what it would look like. So we'll go ahead and pop our lead out one more time. And this time, if we check between T1 and T2, we have 203 ohms. T1 and T3, we have 201 ohms. And T2 and T3, we have 201 ohms. So good balance there. And now if we check to ground, the T1, we're showing pretty much nothing. T2, nothing. And T3, nothing. So at this point, using basic resistance check, we would say that this motor's good. And now is really the first time that we do need to do an insulation test. The difference between resistance and insulation test is resistance can apply a little bit of voltage, and pretty much every meter can do that. Small bit of voltage measures how much resistance is in the circuit. But with our insulation test, when we switch it over to it, then it's going to apply a bigger voltage to it. So since we're on 230 volt coming out of our drag, we're going to put it on 500 volt. And that is going to put 500 volt out on these. So again, make sure you know where your hands are the whole time. But if we put it from ground to T1, and then we do our insulation test, what? Oh, well, here you go, folks. I'm sitting here like, what's going on? This is how easy I do it. We got to check where our leads are supposed to go each time. So yeah, I'm applying 1,000 volt out of these two, and yeah, it's going to test just perfectly fine because I forgot to move my leads over. All right, now if we touch it to T1, all right, so we're showing 0.1 mega ohm, and mainly we were putting up 500 volt. If we look right here, we're only getting 164 volt. And that's definitely telling our insulation is breaking down. So with a minute amount of voltage on resistance, it's perfectly fine. But we apply 1,000 volt to it, then they're leaking by. So that one also shows 0.1 meg and only getting 165 volt. And our third one is also at 0.1 meg and 165 volt. Now, just so we can show how the remote one works, I'm going to unplug the red lead, and we'll plug this one in. And then if I can get up under here, because it doesn't actually work well the way I have this trainer set up. In fact, let me move the camera just out a little bit so you can see even what's going on. But see, I need to get it up underneath here, but mainly I have a button on it. And so if I touch it, that remotely does it. And so yeah, we're at 164 volt. Hopefully you can see that because I can't see the camera. Whereas I'll just hold it midair. That way we can see what it would look like. Is that would be good. So if you really need to do motor checks, I really do recommend the 1587 FC from Fluke, which by the way, FC stands for Fluke Connect, which is really cool. You can get a lot of stuff on your phone with it while you're using it. And I'll put a link to it down in the description. But your next big thing is, okay, don't wait until you have a bad motor. We need to go out and check our good motors and start practicing. See what a good motor looks like. And yeah, okay, you know you had a motor blown up. Don't just throw it away. Let's go ahead and check a bad motor. Let's start learning on our own the difference between good motors and bad motors. I also highlighted a couple other meters here. And I've created this playlist right here where you can learn more about some of those. You know, you have probably 10 screwdrivers at least in your toolbox. You probably need 10 meters in your toolbox as well.